In this video, we'll compare Nginx with Apache web server. We'll run multiple tests, and actually Apache web server can outperform Nginx in some cases. We'll measure latency of each request using P99 percentile from the client side, which I think is one of the most important metrics alongside throughput. Throughput, on the other hand, will be measured in requests per second and will generate enough load to find the breaking point of both web servers. We'll also measure availability or error rates, defined as a ratio of successful requests to the total number of requests. Additionally, we'll measure saturation or how full the services are by tracking CPU usage relative to the virtual machine limit as well as memory usage. Finally, we'll monitor network traffic because these two proxies compress content at slightly different rates. In the third dynamic test, we'll measure how effectively these web servers can function as reverse proxies and manage load balancing. Additionally, in this test, we'll measure saturation of the applications behind the proxies. To run these tests, I use AWS. I deploy large standalone EC2 instances to run Nginx and Apache, and I create EKS cluster with 4 extra large Graviton instances to run my clients that generate load. Additionally, for the third test, I use large EC2 instances to host applications behind those proxies. For the first test, I create AWS VPC and deploy both Nginx and Apache web servers on dedicated VMs. I'm using M7A large EC2 instances that have 2 virtual CPUs and 8 GB of memory. For this test, I use static website generated with React, which compiles to HTML, CSS, and JavaScript files to be served by each web server. I use plain HTTP protocol and enable compression on both web servers, since there are still some use cases for HTTP, and it helps to demonstrate how TLS encryption affects the performance and throughput of web servers. To generate load, I create EKS cluster with Graviton instances and deploy approximately 20 pods per web server to simulate traffic. The second test is very similar, except each web server is secured with TLS certificates. I set up a private certificate authority, issue certificates for both web servers, and provide certificate authority to each client to authenticate and establish a secure HTTPS connection. Additionally, we upgrade HTTP to HTTP2 protocol while keeping the same compression. This scenario reflects a more common use case, as almost all websites on the internet secured with TLS certificates, especially since Let's Encrypt offers them for free. Also, Google ranks websites higher if they use HTTPS. For the third test, instead of serving static content, I'll use each web server as a reverse proxy to route requests to the applications behind it. There are several reasons to do this. First, you can terminate TLS on the proxy and handle plain HTTP directly within your application. This also improves security, since clients won't see your server IPs directly. And reverse proxies allow you to scale and load balance traffic between applications, and it allows you to upgrade applications without downtime. I'm using latest versions available right now. Nginx is at version 1.26.2, which you can easily install from the official repository. Apache, however, is at version 2.4.62, which is not available from the official repository yet. So I had to install it from source, along with Apache runtime, utility libraries, and several other dependencies that needed to be compiled. You'll find a step-by-step guide in README file on how to install the latest version of Apache from source if you want to try it out. To verify compression, you can use curl. When you send a request to Nginx or Apache, you can check the response sizes, which will also appear in both servers' access logs. By adding a header indicating that curl can accept zip, you'll tell the server to compress each payload before sending it to the client. You'll see in the access logs that both servers compress the data before sending it. To test HTTP2, you can also use curl and check access logs to confirm which version of HTTP protocol was used. Also, for these tests, I mount a certificate authority in each client to authenticate the self-signed certificates I'm using for the web servers. All configurations, including Nginx server blocks and Apache virtual hosts, are available in my public GitHub repo. If you see any areas for improvement, please let me know. Alright, let's go ahead and run the first test. Nothing surprising here. Apache's latency is 2 or 3 times higher than Nginx, which clearly shows how well each web servers perform. You'll also notice that Apache uses significantly more CPU to handle the same number of requests, which suggests its throughput will likely be much lower than Nginx by the end of this test. And Apache also uses a bit more memory. Nginx, on the other hand, transmits slightly more data because its compression process creates larger responses. At around 6,000 requests per second, Apache's latency starts increasing. This is likely due to high CPU usage reaching its limit, and availability starts dropping for Apache at this stage as well. At around 8,000 requests per second, Apache can no longer keep up with Nginx. At this point, Apache reached 100% CPU utilization. It may still handle more requests, but with high latency. Now, let's go ahead and find the breaking point for the Nginx. When serving static websites with plain HTTP protocol and compression, Nginx can handle more than 3 times the requests per second than Apache. This configuration is less common today, but if you have a similar use case, this benchmark shows you which web server to choose. Now, let me open each graph for the full test duration. First, we have requests per second graph. Apache started to degrade at around 8,000 RPS, while Nginx held up until around 32,000 requests per second. Next, let's look at the latency graph. Even at the start, the difference in latency between the two was significant. Next is availability graph. Then the CPU usage. And memory usage. Finally, we have network usage. At its peak, Nginx could transfer nearly 1 GB per second to clients. Based on this benchmark, if you're serving static content over plain HTTP without encryption, Nginx is a clear choice. The second test is much more typical today because most websites need to be secured with a TLS certificate. For example, if there is a man-in-the-middle attack, TLS encryption keeps all data like usernames, passwords, or even credit card information secure between the web server and the client. However, using TLS increases CPU load on each web server because each request must be encrypted and decrypted. But since we're using TLS, we can upgrade HTTP1 protocol to more efficient HTTP2 binary protocol. This means that latency and throughput won't necessarily decrease as you might expect. From the latency graph, you can see that Nginx still performs very well, with latency almost the same as in the previous test. Apache's latency is also similar to the previous test, but not in a good way. Apache starts to degrade, which is only 1000 requests per second less than in the previous benchmark. Let's go ahead and find the breaking point for the Nginx. I ran this test a couple of times, because when Nginx reaches 85% CPU usage, it suddenly jumps to 100% and fails to handle any more requests. I initially thought there might be infrastructure issue, but the second time I ran this test, it again failed at around 85% CPU usage. In this test, Nginx was able to handle only 22,000 requests per second, which is 10,000 less than in the previous test. It feels like Nginx could reach 30,000 requests per second at 85% CPU usage, but it consistently fails at this point. Alright, let me open requests per second graph. Next, latency graph. Availability graph. CPU usage. Memory usage. And finally, we have network traffic. Based on this benchmark, Nginx is clearly much better suited for serving static content over HTTPS. Finally, let's run the third dynamic test. Here, we're not serving a static website, but using each web server as a proxy and a load balancer. Behind each proxy, we have two application replicas, and each proxy uses round robin to distribute traffic across these applications. Surprisingly, Apache performs very well in this test. It even has lower latency than Nginx, although it does consume slightly more CPU. What really surprised me is that CPU usage of the applications behind Nginx is much higher than for those behind Apache. If anyone has an explanation for this, please let me know. In this test, we're also using compression and a TLS certificate, which let us upgrade to HTTP2 protocol. Here, Apache continues to perform compression better, resulting in smaller responses, as you can see in the access logs. At around 7,000 requests per second, Apache starts to degrade, and its latency rises up to Nginx. From this point on, their latency are very similar. At around 15,000 requests per second, Nginx shows the same behavior as in the previous test. It reaches 80% CPU usage and immediately fails. In this test, Apache outperforms Nginx. Since Nginx doesn't exhibit this behavior in the first test and I rerun it multiple times, I suspect something might be wrong with how Nginx handles TLS handshake or performs encryption, or it may relate to HTTP2 protocol. Compression is enabled in all three tests. At around 21,000 requests per second, Nginx comes back online for a few minutes and then fails again. This behavior happened multiple times when I rerun the test. At around 24,000 requests per second, Apache reaches its maximum throughput and cannot process any more requests. Alright, let me open each graph. First, we have requests per second graph. Then, latency. Availability. And application CPU usage. These are the applications behind the reverse proxies. Next is the CPU usage of both web servers. Memory usage. Network traffic. And finally, memory usage of the applications behind the proxies. Based on this test, I'm not suggesting you to switch to Apache. However, these results make me want to dig deeper as I use Nginx extensively as ingress controller in almost every Kubernetes cluster I manage. I'm interested in testing other ingress options, especially Apache ingress controller, to see how it compares to Nginx. I also have other benchmarks in the playlist that you might find interesting. Thank you for watching, and I'll see you in the next video.